So last week, we touched on the foundational bits of the introduction to the software testing class, which my colleague Yemi spent some productive 2 hours with you. I'll just wait maybe for a few minutes so we allow some more people to join in, and then we can kick off the class. I can see there are only 19 people here just now. And please, it will be nice if you let us know where you're joining from. So I hope everyone can see my screen. Okay, thank you very much. I can see, Agile, you're joining from Nottingham. Welcome. Thank you for joining us. Admin Bola, I can see you. You're joining from London. Okay, Buki, I can see you. Thank you for joining. So we are 22. If you have a friend or someone that needs to be in this class, kindly send them a reminder so they can join on time. We are going to be moving on into the core part of manual testing. We'll be doing a bit, I'll be touching on the introductory part, just a quick recap, then we go straight into the lecture for today. Good evening, Lekon, you're welcome. Alex, I can see you, you're welcome. Joining from London here, thank you. Yes. So it's 5 minutes past 8. So I guess we'll just dive in straight away, and I'm hoping that as others join, they will meet us at the beginning of the focus for today. So last week, and just before I go, I'll introduce myself. My name is Patricia Emmanuel. I'm a software tester. Currently, I work as an IT consultant with one of the financial services in the city of London. And I've worked basically on different types of projects within the software testing domain, both within the public sector and the private sector. I've tested in different capacities as a test engineer, software developer, engineering test analyst. I believe my colleague Yemi touched on all the types of roles you can find in testing for different companies. It could be different roles, but basically the bottom line, everybody is there to ensure that products are being tested and they are ready and fit for purpose. So please feel free to pop in your questions in the chat box if you have any. Yemi is going to be online to respond to some of the questions. And as well, I might give like a 2 minutes or 3 minutes break in between for us to answer a few questions and then go back into the lecture. So let's crack on. So last week we talked on the background with some examples of what you would need if you're trying to buy a new car. I believe we all remember that example. That this would come with different requirements, and for it to become a whole and brand new product. We made reference to the ISTQB foundation textbook that you need to get so that you are able to do your own further reading in there. We touched on these topics, the fundamentals of testing, testing principles, all of that on the screen there. And we stopped just before we got into the software development life cycle, which is where I'm going to be picking up starting from today. And we have different roles in software testing. And these are the list of roles you can find. You can still find some other roles out there when you go into different job boards to search for testing roles. Some of what we have on this list, okay, are functional and some are non-functional. I will mention some of these functional and functional types of testing and how those roles relate to them when we get to the topic of the day. So please follow through. We also talked about soft skills required for you to be a software tester, and how much and the importance that of those skills for you to be able to get grounded and work on any project to do your testing. Talked about the salary expectations as a software tester. This is just a recap if you're just joining some of the things we talked about last week. I'll pick this up from one of the job boards. And then we also mentioned what qualities are required for a good software tester, using testing as a discipline. And I think, first of all, we say you need to have a passion for it. Anything you are passionate about, you tend to do well and better in it. And then all the other things can come in. Of course, you have to learn the skills as well. So went on to the objectives. I'm going to move on quickly. What is testing? Why is it necessary? General principles of testing and fundamentals of testing, okay? And there was a bit of self-assessment questions, which we follow through. And we also thought it would be good to ask ourselves, is testing for you? And I think in the course of this lecture, you're going to find out if it's really for you. You have to be inquisitive. Yeah, you have to learn how to ask questions, relevant questions, ask the right questions as a tester, pay attention to detail, all of that. Then who can test? I basically say to anybody, when you wake up in the morning, you open your eyes and shut your eyes, you're testing. So if you do that every day, anybody can test. It is not rocket science. So what can be tested? Anything can be tested. Anything can be tested. In this context, we are looking at software testing. So we listed some references for you to go back and look at and search for software testing, manual testing as a whole. And so you can read up on them. We defined testing as an activity that is executed to demonstrate that a software is working as expected. So we expect that when you understand this, you will be able to see it as a discipline, and everything you do on a daily basis, you are able to relate that to testing in a way. And software testing as a discipline, there are different ways of testing. Your testing can be done manually, and your testing can be done using automation. In this lecture, our focus is fully based on manual testing. When we say without any tool, we mean you don't have to write any code for you to be able to manual test. And when we say automated testing, you need to write, you need to understand some code and write some lines of code to be able to test using automation. So I think I've touched on this. So why do we test? We want to test to avoid software failure. And we know that if we don't test properly, something can get lost, something can get missing. So we want to avoid all of that. When we find issues in testing, we describe those as an error, probably because the developer has introduced something that is not expected to be in the code. And the consequence of that is that the software is not going to work as it is as expected. So error is a human mistake. So humans introduce errors into the code, and then the result is something not working as expected. So we talked on the examples of errors. You know, if from the beginning a requirement has not been written properly, or someone has missed something out of the requirement, say for example, the business analyst whose role is to write the requirements and gather that from the business. And I think if some of us have attended the business analyst training, you would understand what I mean, and who a business analyst is. So anyone can introduce errors into the foundational information that we need to be able to write a code. So if that happens with a requirement, that's what the developer is going to pick up. And if we start to trace that back, we trace it back to the business analyst, you know. And in software testing, when you work on projects, you must learn to work as a team with your other team members. Asking questions is good. So if the BA doesn't pick something up and the developer doesn't pick an error up, the tester, you're expected to pick that up, and you communicate that effectively without any personal issue with anybody, because you need to work as a team to deliver on the project. So we talked about defects as well, and we talked about what a bug is. I'm sure we all remember that the consequence of a defect is failure. That means that particular software has failed to perform in that environment where it's expected to do what it needs to do. So we said exhaustive testing of complex systems is not possible. So we will have, when you have to work on applications or products, there are lots of things or requirements that are stated, even in the course of testing, that the application of product will still have to go live, even with some maybe some defects that the product owner or the business feels that it's not going to cause any loss of form, which is acceptable. So we talked about when is testing enough, and we mentioned, we related that to testing and risk, testing and quality, and when we decide enough is enough for testing. So I'll quickly go through where we stopped. We stopped at the psychology of testing, and I mentioned earlier that as a tester, you would be expected to work in a team. Occasionally, you might find yourself being the only tester on a project, or there may be one or two of you, but you would always be working with a developer or business analyst and, you know, other team members. So a variety of people are expected to be involved in the total testing effort. You being the tester means that you are like the police of the product. You give the sign off, you say, yes, this is working as expected, you know, and you append your signature on it to say, I am okay with what I've tested. But at the same time, you have to work with other members of your team. And that helps makes the work easier because everyone is on the same page. So our learning objective for today, software development life cycle, we are going to be talking on that, talking on the different stages and phases in the building of a software. We'll talk about the different models of software development life cycle, the pros and cons. We'll talk about other concepts in understanding testing. So basically, the SDLC, that's what the short form of it, software development lifecycle. It describes the activities performed at each stage in software development and how this relate to one another in order, logically and chronologically. So from the moment a decision is made to develop software, the models to deliver the software would have been agreed by the business. So you see these two examples. We have the waterfall model and we have the V model. These are sequential development model. The waterfall model is relatively a traditional approach. And before I go into that, I would also like to talk about the other types of models. So we have the rational unified process, we have the spiral, we have the Scrum, we have the Kanban and Kanban. So I would say ignore the V model. This isn't part of it. The V model is one of this, is a sequential development model. So we've got just 4 of that. So looking at this, I've kind of splitted them into 3 because we have the kind of activities that happen in the waterfall model are linear. And when we go into the V model, the activities, instead of moving in a linear way, they are bent upwards after the coding phase. I will touch on that. And we have the iterative incremental development models too. Please, if I'm going too fast, let me know. So that is the waterfall model. As you can see, the activities move down in a linear way. Each phase of the waterfall model must be completed before the next phase. When it's raining, the water is coming from above. So if you remember that, you remember the waterfall model of the software development life cycle. The phases do not overlap. And for each of the phase, requirements, design, development, testing, deployment, and maintenance, the goals are defined. What needs to be achieved for each of the stage. Each of the stages are defined, okay? So at the requirement stage, and which basically every type of model that we will mention here will always have some sort of requirement. So for the requirement stage, that is where the user or business requirements are defined. At the design phase, as you can see, once the requirement phase is completed and everybody is happy, move on to the design phase. And this is where the design comes in to say, how do we design the system? What is the system going to look like? What's the structure? Would we have database? Would we have what components are going to come together? This is where all the architectural design are defined. We have the development phase. At this stage, this is where the developers start to write the code. And at this stage, the developer is basically relating with the business analyst and just writing the code, writing them in units and testing them. You're using their unit testing, the type of testing that developers do. And when they are done, that phase is completed. That is when they bring in the tester. The tester comes in at this stage to start writing the test plan or test script and get the system tested. And this is where testing is done. Testing is done only after the coding of the entire software is complete. Isn't that interesting? So imagine you building, saying you want to build a house, and you can't even check anything. All you just want to do is that you're just informed that the house has been built, and then you're invited. The house has been built, everything finished, the roof is there, all the doors have been fitted, and then you're invited in to come and check everything in the house. I know for some of us, you'll be thinking, wow, I don't know what to, because you don't know what to expect. Personally, I'm not going to know what to expect. And then I come in, I have to, with the assumption that all the development has been done and everything has been done according to plan. And I go in and I kind of find something that I feel that, wow, this shouldn't be here, But at that stage, everything has been completed and handed over to you. So what do you do? So we're going to talk about the pros and cons of the waterfall model. So the tester comes in after the entire software coding is completed, and deployment is the next thing. They release the product to the customer or the user, and the rest of it is maintenance. Now, one of the pros that you can see here is that all the phases are completed one at a time. Yeah. If it's for a smaller project and all the requirements are well understood, they are simple, straightforward, no complexities, this waterfall model is probably the best way to go. Otherwise, if something goes wrong in the later stage, I found out that I've been asked to come and check all the windows, the doors, and I'm there, and that is at the testing stage. And I'm looking at the requirements, the test script and all that, and I can find that there are errors. In fact, that the right type of door frames have not been used. You know, it becomes expensive. You know, I can't sign that off. But that is at a later stage. And there may be no chance of going back. So that is waterfall model. If we take a look at the V model, it looks like an extension of the waterfall model in a way. The development phase is here. Instead of moving down in a linear way, when it gets to the coding phase, as you can see, when it gets to the coding phase, you start to form a typical V shape. Okay, so we have the user requirements, we have design, we have the software application where you have the system design, and we have the architectural design as well, which is a high-level design. Then we have the component design, the module design, which shows you all the tiny bits of components design, and where for each of the stage, some sort of testing takes place. Okay, some sort of testing activity takes place. So it goes straight into the V shape. It forms that V shape at the coding stage. So at each stage, separate testing is associated with each of the defined project phases. So the projects are in phases. So when the coding is done here, the testing activity that takes place at this stage is the unit testing. At the architectural design phase, this is another development phase, which is where the high-level design happens. At this stage, we are having interactions of components together. So some sort of testing takes place there. That is integration testing. And if we go back to where we have the actual software application design, the system design itself, that phase, some sort of testing, system testing is happening, and up to the final stage, where we go back to our user requirements to check, to do our acceptance testing. So all of this is planned in parallel. Okay. So for every single phase in the development cycle, and there's a direct associated testing phase, some sort of testing activity needs to happen there. Now, we'll have verification taken on one side, as you can see on the left side, and our validation is the activity that is taking place on the right side. So each developmental phase, some sort of verification is taking place. And as we are moving from each of the developmental stage, we are also checking if we are building the right product. Now, if we talk on the pros of this type of testing software development model, the V model, we're talking about the V model. Testing early in the life cycle enhances the probability of building an error-free and good quality product. And I think this is one of the things that is industry standard. Test early from the start, from the moment you get the requirement documents. So, which for the V model, that sounds like a lot better than what we can see in the waterfall model. However, if we go to the cons, we will need we will spend a lot of time trying to update documents. We update the documents, you update the requirements. If any changes happen midway, unlike the waterfall, you complete each of the stages and then you sign that off. You say sign, seal, deliver stage, development stage, and then move into testing stage. So for the V model, we have to be ready to update documents and make sure that none falls behind the other. So I'll quickly touch on the differences between verification and validation phases. I hope you can see my screen clearly. So we have the business user requirements. If you look at this diagram, so I've just placed this so we understand what is happening there. So at this stage, the details of requirements of the software are gathered from the client. When we say client, the client can be a business, the client can be a third party, okay? The client can be a company, so the client can be an individual, who has an idea of who has an idea of solving a problem, because people build softwares to solve problems. So at that stage, the validation that happens there is acceptance testing. And that involves testing the product in the user environment, like how the user would use the product. So that's basically. Then the software application design, that's the stage where the question of how will the system work, how will the system interact, what components will the system interact with, the functionality that goes into the system. Those are the things that happen there. Then we have the system testing that happens there, checking the entire system, all the functionalities, every feature talking to each other, the behavior of a system. So that's what is happening there. Then we have the architecture and high-level design of the software. I mentioned that earlier. Okay, so this is where we have coexistence of components, that make up the system. We could have maybe there's a third-party software, or there is, or maybe we have a database, and then we have the actual system that we're working on. So we also have to test that those components can coexist. So at this phase, integration testing is done here to test the coexistence and communication of internal modules within the system. Then we have the detailed design. So once your system is ready to use, here you can later require change. Maybe the customer has requested a change, and this is where the coding happens. And of course, basically, when developers are writing their code at this stage, they make sure that every unit of code that is written, meets the requirement and is also tested. And if there are issues found, they can easily identify which module has an issue. So I'll move on to our iterative and incremental development models. Now, if you remember, I mentioned there are 4 of them. There's a rational unified process, if you remember those colorful boxes in the previous slide. So for that one, for the rational unified process, which is a form of incremental development model and iterative, this one, the iteration is long. It could take a couple of months, and the features that are delivered at that stage, they are large. So I would say, imagine if you want to build a house. I'll still use the house example, and the person you've contracted the house to, your agreement is that every month they need to deliver a room, a house. Your intention is building a house of 7 rooms, and you say, okay, every month just deliver a room, completed everything in a month. That means that for the 7 rooms you need in the house, you're expecting 7 deliveries, 1 room each month. So that's like what we call the rational unified process. Now, I'll talk on the Scrum, which is like the most popular one. So in a Scrum development, each iteration is short. In fact, it can be broken down into multiple standalone modules of software development cycle in bits and chunks, okay? And let's also think about it like this. When we say incremental, so the requirements are broken down. If you look at this diagram, you can obviously, what is obvious here is that we can see that there's some sort of incremental thing going on here. That's the first incremental delivery. Okay, we move on to the next incremental delivery. We move on to the next, we move on to the next, and then we move on to the final stage. Okay, so each iteration passes through the phases, but it's delivered in iterations. Even though we say phases of requirement design, coding, testing, and software product increment. So what I'm trying to say is that For each of the subsequent release of a system, we are adding something. Let's take a look at this diagram again. We start here. I'll go back. We start here where I have my arrow, my cursor. We start here, and then at the next stage, we are adding something. Okay. So this kind of model makes it easier to detect when issues happen. Okay, because we have a set goal. This week, we are going to do 1. The following week, we are going to do 1 plus. The week after, we are going to do 1 plus 1. So that's the kind of iterative description I'm trying to describe here. So I'll go back to the house example. Imagine your building contractor is delivering something to you every 2 weeks. Okay, first, deliver the door. Second, deliver the window. Third, deliver the wall. Okay, and then deliver a room. Unlike the rational unified process where it's just delivering the whole room in a month. So that is what we call Scrum. And when is it used? If you want to get anything quick and fast to the market, just the basic functionality, you can use this type of model. For some of the reasons I'm going to talk about now, when you deliver it quickly to the market, the users or the customer can provide feedback for each of those iterative, each of those additional increment of delivery. So at the end of the day, nobody is surprised. They provide, you are able to show them, they come back and say, okay, we like this, however, can it be like this? Because everybody wants something better from what they've seen already. So changes to what the customer wants can easily be accommodated and can easily be fixed without costing much. Okay, now what are the cons? To be able to do this successfully, effective planning of this iteration is required. Okay, an example of planning effectively for this type of iteration is that you want to deliver a building in iterations. Obviously, you can't plan that your building will come before the foundation. Okay, so that's a kind of effective planning that we're saying. What are you going to put the building on? There's no foundation. So that is an example. And if you look at this, I know if you're here and you've heard a lot about Agile, you're wondering, Agile. I know some of us have attended the Scrum Master training. Can you please put that in the chat? You know, so, and that is what we call the Agile Scrum delivery. So for every iteration, there's an increment in the software product that is being delivered. So we are doing something better. We are adding a new functionality. We are making changes to something that we've done, you know, to make it look better because we've gotten feedback from the customer, from the client. Okay. So as you can see in this diagram, we have how many iterations have we got here? we can obviously see that we have iteration 1, iteration 2, and then we go on and on till we have the final iteration that delivers the entire software. Okay, so, and for each of these iterations, the iterative delivery, requirement analysis, design, and coding still takes place, and testing takes place in tandem. And if we look at this one, you might have seen this type of image in your Scrum, Agile Scrum training class. This is a sort of sprint delivery that we'll be using, this type of model we'll be using in the internship. So if you've not registered for the internship, I would say please avail yourself the opportunity, because how much of a talk I do here, I know for some people it might, you're still looking at it like, oh, I'm not sure I'm getting this, but trust me, you're getting it. But you get it better when you are able to experience it. So requirements will be put in the backlog. As you can see, there are just some terms you're going to get familiar with. They are put in the backlog, you know, they go through planning, and they are prioritized and added to a sprint, and prioritized, estimated, and added to a sprint. And then development starts and testing takes place. And then we come back to deliver that particular iteration and pick other plan and sprint plan for other requirements and deliver incrementally. So for every iteration, I would say that testing happens early. It happens from the moment requirements have been defined. So I have got some other examples, some other images, so it gets a bit more clearer to you, whether you have those images horizontally or vertically, so you can see that when you are delivering in different builds, you still have to design and develop, you still have to test, and then you are able to implement and deliver the project. But everything all starts from the requirement, as you can see from this diagram. So the other types of iterative and incremental development models, you can go and read them up. We have the Kanban. The iterations are either fixed length, and they can be delivered as at when they are delivered. Like you get delivery of your door in a week, you get delivery of a room after a month, or they're delivered when it is ready. That's how Kanban works in simple terms. You see that they are fixed or not. So you can have requirements delivered in bulk, or you can have them delivered in pieces. So the spiral one, this is where we have more of exploratory kind of delivery. Sometimes users the business have defined what they want. However, the entire product, the entire requirements that they need have not been fully defined. So they can have something like a prototype delivery. Say you want a brick house, and then you get to plastic house delivered first. So from you seeing what the plastic house looks like, you are able to imagine what the brick house would look like. So that's a part. And software development models are selected based on the type of products. It's just so you note that they're based on the type of products. They are also based on what is priority to the business. The model selected they're also based on the goals and the height of risk that the company can take on, and also the company, the software development company or the business, they will also look at the resources they have got. So, but when projects are like very complex, different types of models can be adopted. And when we have projects like, okay, maybe we want to develop something on the front end quickly so we can show the customer and they can give us feedback, mostly people use the Scrum method model. So in summary, everything we've talked about relating to the models, there are some general activities that takes place. If you have noticed, there's requirement development, there's design, there's testing. We have similar types of testing taking place. Sometimes, deployment happens, the release into the user environment, and afterwards maintenance and all that. So that is that about the software development life cycle. If you will take a short break, I hope everybody is still alert. You take a short break, maybe get some water to drink, like I am doing now. Then we'll go straight into the different levels of testing that you can find in any project. I hope everybody is still here. So if you need to drink water, if you need to stand up and stretch, please do. So we all need to be alert for the next part of this. Okay. All right. Okay, what is unit testing? But please note, yeah, oh, great. Thank you, Akbio, thank you, Rook A. Thank you, everyone. Yeah, thanks. Glad to see that everyone is following. So test levels. Please note, these are the 4 major test levels that you would find in software testing. We have the unit testing, we have the integration testing, we have the system testing, we have the acceptance testing. Okay? The unit testing, let me take you back. I'm going to just touch on this. As you can see, it's also the component testing. So at this level of software testing, individual units, individual components of the software are tested. And the reason for testing this is to validate that each unit of the software performs as designed. Okay? So if anybody asks you, when you're testing individual software components, what are you doing? What you're doing is unit testing, but this is usually done by developers. Please note, the developers do unit testing, okay? In the course of your career in testing, you may find yourself in a role where they are asking you to do the unit testing, but fundamentally, it is done by developers, okay? So if we go on to the integration testing. So the integration testing is a level of software testing where the individual units, please note, individual units and components, they are combined and tested as a group. Okay? Now, the integration testing is done to be able to expose any fault in the interaction between these integrated units. All right. Now, when it exposes, when this testing is done, if there are errors, if the errors have been introduced along the line, it exposes that. Okay. Sometimes you would see component integration testing. You are testing the interaction between integrated components. Sometimes you will see system integration testing. You are testing the integration of the systems and packages. You are testing the interface to maybe external organizations. Sometimes you will have different systems, interacting. So you also need to note that that exists. Okay. So system testing. Okay, just before I go, don't forget that integration testing happens after unit testing. Okay. The unit testing happens, then integration testing happens, then you perform system testing. Please note, integration testing also is usually conducted by developers, okay? And the system integration testing is performed by independent testers, okay? Because they are looking at different systems talking to each other. So if some sort of data is being exchanged between different systems, we call that systems integration testing. Now, so if we go on to the system testing, which is done after integration testing. Now, system testing is that level of software testing where a complete and integrated software is tested. The system is complete, it's been the software are integrated. Then you test the entire system as a whole. So when you're doing this type of testing, you're doing that to evaluate and validate that the system that you're testing agrees with the specific requirement. Okay? So it could be more comprehensive, okay, at this stage, because so many things are being tested all together. And this is where, I don't know if you've had some exposure to testing before, you will hear, oh, end-to-end testing, okay? So that's the third level of a software testing. We are talking about test level. So that's the third level. Unit testing happens, integration testing happens, and we go on to the system testing. So there are lots of things happening at system testing stage. I'm going to talk about them. That you are, you are going to be smoke testing. You're going to be doing regression testing. You're going to be doing retesting. You are going to be doing some functional and non-functional testing around this side. And that's where sometimes you go on the job board, you're going to say system tester required. So that's what they're asking you to come in to do for them. Okay, so you are testing the entire system as a whole. So the test environment will be close to the production environment as much as possible, so that you'll be able to pick up anything that you don't want to come as a surprise when it gets into production. Production is a live environment. Okay, so if you go on to the acceptance testing, I hope I'm breaking this down well. Okay, so if we go on to acceptance testing, that's a level of software testing where you test the system for acceptability. Okay, so you're testing that the system agrees with the business requirement and it is acceptable for delivery. When you say it's acceptable for delivery, it is worth somebody putting their money down for, to say, yes, this is exactly how I want it. Okay. And that has been delivered with respect to the needs of the user, with respect to the requirements, functional and non-functional, and with respect to the business process. So that satisfies that, okay, these are our acceptance criteria. Our users are able to use it. Okay. Only the people that are authorized to use it are able to use it. Okay. Everything we have written relating to the type of components that need to be integrated together, the structure, it's working as required. Okay. And then we say we can sign that big check and pay this software company for delivering this. Okay. So, I mentioned that when you are system testing, a lot of things go into that. So we have, this is where we go into the different methods of testing, different types of testing rather, that goes into system testing. So as you can see, I've put down the functional testing that covers the the testing that happens here is testing against a functional requirement. Please note, in software testing, we have functional requirements, we have technical requirements, okay, and we have business requirements. So I think sometimes the functional requirements and some functional requirements can also be described as functional specifications. and there are some other business requirements. When we say business requirement, there are some rules that the business or they would want the developer to apply, the development team to apply to the software they are building. All this goes into the specification. So for the functional testing, testing is performed to verify that the component satisfies all the functional requirements. So different functions or features have been put in place. Say we want a login feature, we want a registration feature, we want a search feature. I'm just giving some examples here. We want a search feature, we want an upload feature, we want to be able to upload documents, So note that this type of testing is not concerned with how we are able to, how the process occurs, but this type of testing is concerned with the results of the processing. It's concerned with the behavior, okay? Please note that functional testing. It's concerned with the behavior. It's not concerned with how did they put this, It's just, am I getting the result? Is it behaving as I expect it to behave? Okay. So in the functional testing, we have smoke test, we have retesting, we have regression testing. So the smoke test, I'm sure some of you have heard smoke test, you're wondering what that is. Okay. This is just a set of tests that you run to decide if a particular build is stable enough for you to proceed with further testing. For example, I'll give you an example. We are developing a website, okay? And I've been given the link to the website, and I put that link in my browser, okay? And I can't see anything. What I've just done is a smoke test. Can I proceed if that link takes me nowhere? No. So that is a simple example of a smoke test. So that tells me that it's not ready. I can't proceed. So if we want to talk about retesting, now I have identified a defect in a particular functionality, okay? So I've identified an issue with a particular functionality, and when the developer fixes that particular issue, let me just say, for example, I'm trying to log in and I'm passing in my valid username and valid password, and I can't click the submit. When I click the submit button, it does nothing. Okay, that is a defect. I should be able to click the submit button and see that my login has been successful. So I've done all my checks, and what I've reported that, and the developer basically fixes that issue. The developer says, okay, it is working. When the developer passes that back to me, I'm still going to go through the same steps that I went through before reporting. I'm going to enter my username, I'm going to enter my password, and I'm going to click up on my submit button, okay? What I'm doing at that stage is retesting, okay? What I'm doing at that stage is retesting. Some people call it confirmation testing. I am confirming that a defect has been fixed. Okay, can you retest that? I need to retest that. Developer says it's been fixed, I'm confirming, so that is retesting. Okay, now I'll move on to regression testing. So I'll give the same example. Before I reported that failure in my ability to submit, my inability to submit after after clicking on submit, every other functionality around that has been working perfectly. Okay, so imagine you're on a website, I don't know, maybe Tesco's or Asda's or wherever you're shopping, and you have the submit button, and you have another button that says click to reset your password. Okay, just imagine that. And you have actually tested the click to reset your password. When you click on that button, I'm talking about that button, because that button is your way in to be able to go through resetting your password. So when you reported that you can't submit your username and password, nothing was wrong with the button beside it that says click to retest. Okay? And the developer has come back to say, can you confirm the submit button? Can you retest it? It's working. And you do the retesting on the confirm button. Okay? You're testing on that build, and that is working. And you decided that, okay, let me check this click to reset your password button sitting beside your submit button, and that button does nothing. Okay, what you have done at that point is regression testing. Now, what has happened is that when the developer changed the code to fix the submit button, somehow that change he made has introduced a bug to the submit and to the reset password button sitting beside the submit button. Okay, so when you decide to test that, that is regression testing, because you've actually done your retesting on the functionality that failed. But however, you decided to test the functionality that was working already, and that one, you'll find out there's an issue. So that's a defect you've identified doing a regression testing. So what does testing do? You're able to verify and validate that a software hasn't got a bug. You are able to identify if a software has a bug, and you're able to identify if a software has failed. Now, when you report a bug or a failed software defect to a developer, the developer starts to do something. Okay, it starts to debug. In a way, testers, manual testers too, debug. And your own sort of debugging is where you are actually doing all the checks you need to do from the manual testing point of view before you're reporting the failure. You've done all your investigations. Number one, you're sure you have the right build. Okay, because when we say builds, these are the implementations, the version of the software that the developer is handing over to you to test. So you must do your checks that you have the correct build. not the build from 2 days ago, for example, okay? Because it's possible the developer comes to you and say, this issue has been fixed, and you do a retesting on it, and you go back to say, oh, it hasn't been fixed. But let me ask you, have you checked if you have the right build? Okay, that's your own sort of debugging. Okay, if you've got the right build, okay, that is fine. You are still on course. But if you've got the wrong build, you need to ask the developer to deploy the right build for you to be able to test the fix. So debugging helps you to remove error. It helps you to identify and analyze. And please note, as a tester, you need to be analytical as well. You need to be able to analyze defects, analyze bugs, you know, analyze requirements, which is a major, you need to be able to analyze requirements. So in the course of building the skills, investigative skills, you know, you would also learn how to approach this, because there are so many things that comes together for you to understand how testing is done. Okay, we also have the non-functional types of testing, and we all know we have performance testing, where we test the that helps to determine how the system performs, its responsiveness and stability under a certain load. You know, what is this system going to work if we have like 1,000 users logging into it at the same time? You know, all those kind of things. This fall under performance testing. It helps to test the efficiency of the system. It also helps to check the stability, the reliability, and how scalable the system is as well. You know, we don't want to build a system that falls apart when 10 people are logging in at the same time. Okay, so the different types, you have load testing, stress testing, endurance testing, spike testing, yeah, all those type of testing, volume testing, you can read up on it. We have security testing. And I must say that all these types of testing, they are kind of in the specialist domain, yeah. But it's always good to have the basic knowledge of testing, even if you want to specialize in this type of testing. Not many people, there are not many people out there who do this. They're either combining other forms of testing with this, or some just basically do this as their area of specialism. So the security type of testing, it helps to uncover any sort of vulnerabilities that the system might have, so that it can protect data and resources from intruders, from possible hackers. We know who hackers are. They're hacking WhatsApp and all that these days. So the level of security testing is expected on our software. Then I'll touch on usability testing. Okay. This type of testing, the usability testing is different from acceptance testing. So this type of testing helps you to determine which software product is easy to use, easy to learn, easy to operate, attractive to users under specific conditions. So you're able to, you pick up a software that you've never seen before. So you're not even testing against any requirement. You're picking. I think we see all those kind of software these days. If you use a lot of apps, or you do social media a lot of times, you're going to see some apps. You just pick them up. You definitely know what to do with them. You know what you're looking for. So that kind of testing is usability testing. So it's easy to learn, easy to operate. Okay. Even if you need to explain to anybody, you just show them once and they are fine. Okay. So Then there's another type of testing I said I would mention here. So you could find yourself working in a regulatory and compliance company where even their policies and all that are incorporated into rules that needs to be applied in their codes. Okay, so don't be scared. You would find some of this, especially maybe in the financial sector, even in like I would say financial sector, in the aero, yeah, in the airline, yeah, anything related to software relating to airlines, relating to airlines, you would find such financial sector majorly. So there are rules that would, in terms of conforming to regulations and standards, you will be expected to execute this type of test. The development team will be expected to implement codes that would ensure the compliance of the system. Okay, so this is also compliance testing, and I think an example on the website is the where you log into the web and you have that pop-up that comes to your face to say that, do you want to accept cookies and all that. So those are also part of compliance testing that you do. That is this website complying with the regulation of a country or wherever they may be. So that's a simple example. There are standard sets, you know. There are also standard sets that web pages must be responsive, or they must be HTTPS enabled in all web applications, you know. So all those things, some are just industry specific, you know. So I know you all understand what I mean yeah by that. So so also we have structural testing, and we also have sanity testing. So I think if for sanity testing, that type of testing is the kind of testing that is performed when when you maybe some sort of code change has been applied, and we've done the regression testing. Okay, maybe we just decide to check whether to test the build, that particular build of that software where the code change has been, where the regression testing has been done. We tend to check that one to be sure whether we can proceed, you know. This kind of testing, I would say, please note this. If we need to deploy anything to production, like immediately, maybe like a critical bug fix, yeah, this is where you get to do sanity testing. Okay, because you've done the retesting, you've done the regression testing, and then we just say, let's do some sanity checks. So you do that where some sort of immediate deployment is required. So for structural testing, I'll touch on that in the further slides, because we are going to be talking about the different types of the structure-based testing. We'll talk about structure-based testing. I'm sure if you've heard about black box testing, white box testing. So, and yes, well, let's talk about static testing. You know, I said that that it's good when we have when we understand that testing should be done very early. So static testing is a type of testing technique. You know, when they say something is static, okay, you are not executing anything, you're not running anything, you are just, static is there. So you have the requirements, you know, the requirements is a sort of documentation written. By the way, sometimes you find yourself in an environment, the requirement is not written. So you have to learn how to work in such environment and how you can add value to that kind of team to ensure that some sort of reference is somewhere for everybody to look at. So requirements review is a kind of static testing. For example, if I type something in, maybe, okay, say I'm preparing this slide and I say to my colleague, Yemi, I say, okay, Yemi, can you review this for me? So basically what she's doing is static testing. She's looking out for maybe an information that I've added I shouldn't have added. She's looking out for some errors that I've introduced while building the deck. You know, that what you're doing at that point is static testing. You know, a business analyst has written a requirement that the website, the background page of the website must be blue. Okay, the developer picks it up. Nobody has done a static testing on it. The developer picks it up and puts in ocean blue. Then the user says, I didn't ask for ocean blue. I said blue. But if somebody has done the static testing of that, and somebody has had the right question, they would have picked that up and said, okay, blue, what sort of blue? Light blue, baby blue, you know, that kind of thing. So you get to identify things like that in static testing. So codes can also be tested using static testing. So, and these, well, developers, they can review each other's code, you know. So dynamic testing, this is done in the validation stage. We are validating if what we are building, if we are building it right, okay? So at this stage, we are just executing the code, okay? We are not checking the code if the code written is right. So that's the difference between static and dynamic testing. So we do have review. So what is a review? When you are static testing a document, you are reviewing the document, okay? You are reviewing the document. What is the goal, the aim of the review? You are looking to find and remove errors. Sometimes you may be asked to write a test plan for a particular project and all that. You still have to give it to somebody to review, okay? So it says here, we say, giving a draft document to a colleague to read is the simplest example of a review, and one which can usually yield a larger crop of errors than we would have anticipated, which is true. We all write well, we all speak good English, you know, we know how to dot our I's and cross our T's, but trust me, sometimes, you know, you want to get better, and you also want to make sure that your work is clean and neat. That's why sometimes we do documents, we have to spell check them, okay? Make sure all these little skills here and there. And you can also make sure that you can check them with your colleagues, okay? So and there are different types of review. So we have the informal review, we have the walkthrough, we have the technical review, we have the inspection. So all these types are, all these on the list are types of review. For your informal review, you could be the one organizing that, you know. You can request for a member of your team to just review a document with you. And for a walkthrough, sometimes we find ourselves asking for a walkthrough of how a system works. So in this situation, you are probably given a demo, okay? You're probably given a demo to a group of people, or somebody is giving a demo to you. So you are not just looking at the document, you're not just looking at printed images, but they're actually walking you through. It could be a walkthrough on the process or a workflow of an application. It could be any of that. Also, sometimes you might require a technical review, which would require maybe somebody, which would require the presence of a developer, okay, in this kind of meeting, okay. So sometimes you call it peer review, okay. So like if you're a junior tester or a junior developer, it's something you get somebody who is more qualified, who has more experience sometimes. Yeah, so you go through the review together. Sometimes it could be that they are walking you through the code, or how everything hangs together, how every component hangs together. So it helps to examine the suitability of the products. And during that review, that's where if say, for example, those technical reviews. So that's, for example, when developers do that, they're able to point out some things that could say, oh, you could have written a cleaner code, or why don't you try this? And know that, at some point, maybe they are probably been mentoring you. And also, we have the inspection. So inspection in software testing. So in this one, it's like you involving your peers to examine a product, or you invite your peers to look through documents and check that they have been thoroughly prepared, and before you go to the wider audience, so it helps to correct whatever defects in any software artifact, which is also a right way of working. So don't think you get into a software testing role and you want to work in silo. You have to make friends. You have to identify who can help you in the team, so you also have to be teachable. Yeah, that's you have to be teachable. So you may have better knowledge in some other things. You are probably transferring your skills, but you don't work in silo. All right. So let's move on. So understanding, excuse me. Now we're going to talk about, excuse me. Sorry. So we're going to talk about test case design. Now, in software testing, okay, we have test conditions, we have test cases, we have test scenarios, So when we say a test, when we say test condition, what we are trying to say is, thank you, Lekon. I have a bottle of water beside me, to be honest. I think I just kind of lost it there. Thanks. So when we say test condition, we are talking about an item or event of a component. So look at it this way. There's a component or a system that we need to verify by at least one test case. Okay, simple example. I want to verify the condition. I want to verify the login functionality. Okay, and the condition I want to verify is if I use valid credentials, will I be able to log in? Okay, so that is a test condition. The login functionality is what we want to verify with one or two test cases. Excuse me. And the condition we are trying to verify is using the valid test case, okay? So, and that takes us to our test case. So, when we have a set of input values, I've said that I've given the example that we have a login, okay? We want to be able to verify that our login works using one or two test cases, okay? So our login is that item, is that functionality on the system, and we can verify our login with a test case, okay? So when we pick a particular test case, we are also looking at what we need to use to be able to verify that condition. So we are looking at the input values. We are looking at the data, okay? So, and our test data, okay, please note, we have test condition here, we have test case. Now, the set of input values, the execution preconditions, and expected results. These definitions are the definitions in our ISTQB textbook, okay? So, a set of input values, the execution conditions, the expected results, and the execution post conditions developed for a particular objective or test conditions, such as to exercise a particular program path or verify compliance with a specific requirement. The requirement is that I must be able to log in with a valid username and password. Okay, and I am writing a test case that allows me to verify with a valid username and password. When I'm able to use those invalid username and password to verify that condition, okay, I am able to report on the execution I have done. Okay, so you need to understand what your test condition is. You need to understand what your test case is, and you need to understand what your test data is. When we are coming back next week, we'll go into some specific examples. I'm sure I have some here anyway. but it's important that we understand this. We know what our test condition is. We verify a particular item or a system. Is anything you are able to verify with one or more test case, okay, is a condition that you are, that's your test condition. That's it. As long as you're able to verify with one or more tests, you can actually write a test case to verify that this feature works. Yeah, that's your test condition. Okay, so then we have our test scripts. Okay, now your test scripts consists of your test steps. It consists of the process you're going to take, to execute a particular test case. Okay, so that's an example. If you are able to navigate or open 2 different windows while watching this, I would ask you to follow this. Just follow the test condition. So if you look at this, yeah, I'll walk you. What I'm doing now is just a walkthrough, so you understand. Then I would say, let's attempt the first one wherever you are. Now look at this at the top. This is a website, www.gifttree.com. Now your first column is a test case ID. With the test case ID, we're able to identify the condition that we are verifying, okay? What condition are we verifying? We are verifying the sign-in condition. A user must be able to sign in with valid details, okay? That's the first test condition. The second test condition is that a user with invalid details must not be able to sign in, okay? Now, if you look at your first row with the test case ID 1, when a user is able, when the condition says sign in, our input value there is a test case because we are going to be using valid details, okay? So let's assume the details we've put in here are valid, okay? But for this website, you will not be able to submit if you have not registered on this website. So if you register on this website, you know what your username is, you know what your password is, then you should be able to log in. You're signing with the sign-in which you're trying to verify, you should be able to do that. So if you go to the website, www.gifttree.com, that is your test step. Is this also describing what you need to do? Your expected result, which is what the requirement is that once you go there, you must land on a page. You must land on the page. You get on the Gifttree landing page, okay? There's a landing page for that website. Now, if you land on that page, when you execute the test, when you put www.gifttree.com in your URL, if you type that in and you click on your browser and you don't get on the landing page, whatever you see is what you put in the actual result column. I hope everyone is following. Whatever you see is your actual result, okay? Your expected result is what is the behavior we expect from the software. The actual result is what you are actually seeing, is how it is behaving. And the status is what you as a tester will determine. I am expecting A, I see B. What will my status be? Can somebody put that in the chat? I am expecting A, I see B. What would my status be? Pass or fail? Can somebody put that in the chat? Thank you, Richard. Yeah, thanks, Obina. Thanks. Wow, awesome. Yeah, everyone is following. Yeah, so that is it. So that is you. You are able to identify that there's some issue there. Okay, that's fine. So say, for example, we go through all of this and everything works as expected. We'll do some practical sections next week. You see, you have, this is like a template of a test script. Yeah, thank you. So thanks, Nico. So sometimes when you, and please note when you're just the straightforward in your reporting, your test is either pass or fail. That's it. But sometimes maybe you're executing, you say you are blocked for some reason, maybe at some specific steps, something is not allowing you to move forward. You've passed the first 2 steps, so but something is missing for it, and it's not your fault, it's not the developer's fault, you don't know what, maybe you're blocked. But always know that your test is either the test is passing or it's failing. So some steps could pass and some steps could fail. So this is, I don't know if you've been hearing test scripts, this is what a test script looks like. If you are writing manual test script, your test script is different when you're writing automation, okay? Because in automation, you need to write some codes, okay? So now, assuming we've executed the test, now look at this. This is a test script that is ready for execution. This is a test script that has been executed, okay? So you've gone to execute the test and you are coming back and you've been able to tell us you have a pass, you've done all you need to do, So please note this. For next week, we'll go through, we'll get hands-on with this, with examples, and I would like to see what everybody is doing. We will be more interactive. And I would move on to the structural testing. I said earlier that apart from when we do tests, we need to also understand what goes in and what comes out. As you can see, these 2 boxes, you can see that one is black and one is white. And these are called black box testing and black box test technique and white box test technique. Now, when we say black box testing, it is also known as, okay, what's that name? Behavioral testing. Now, when something is black box, like imagine you're seeing a black box, it's black. You can't see the internal structure. You can't see any design. You can't see what is going on inside. So you're not expected to know what is going on inside, okay? So this test can be functional, it can be non-functional, but it's usually functional. And we also call it specification-based techniques. Please note that in the ISTQB exams, I think sometimes they will refer to specification-based techniques. You'll be the one to figure out if it's black box or white box. So, and there are 5 types of it. We have equivalence partitioning, we have the boundary value analysis, we have the decision table testing, we have the state transition testing, and we have the use case testing. So you don't need to have the knowledge of the code that is written. So then you'll be able to execute your test regardless. All right. We have the structure-based testing. Hold on a second. We have the structure-based testing techniques. That's the white box testing. So for the white box testing, you are going to be testing when you, so that you don't forget. That's where I remember white means that, well, I can see clearly, so I can also see anything that is inside. Is open, is clear, it's like glass. So white box testing is based on the analysis of the internal structure of the component or the system. So you need to know what is going on. You need to know what code has been written, So the sort of programming, a level of programming knowledge is required for this. Let me just say that straight away. So because you will need to understand when some valid and invalid inputs have been introduced into the system. Okay, so you need to understand how a code is implemented. You need to understand that a bit. But for black box testing, you don't need to understand. But to be honest, I would say to you as well, even if you want to understand white box techniques and still stand out as a tester, when you have a good understanding of the black box testing techniques, the examples I'm going to be coming with next week, we'll go through all of this once, because I believe as a manual tester, you also need to be grounded and in being able to apply the different types of testing techniques to products, so that even when you move on to automation testing, it just helps you. You're able to apply the knowledge of this when writing test cases, say you're writing automation test cases and all that. So we'll touch on this more on this test basically next week, but I would just like to just explain a few you can go and read it up. So for the equivalence partitioning, so this one involves, when you have a set of input values and you can divide them into valid and invalid partitions. You divide them into valid and invalid partitions and select a representative from each partition as your test data. It will be good when I give more example. I hope people are still awake. Don't worry, I will be logging off soon. So then the boundary value analysis. So in this case, you are able to determine the boundaries for input values, say, or if the requirement says that you must only be able to use positive numbers for a particular functionality, so, and you have your numbers from minus one to 10. Okay, so you want to test for input values that are at the boundaries. It's just going to be inside and outside of boundaries, and the requirement says you must only be able to use you must be able to use values at the boundaries. You must be able to use positive values, basically. Now, at the boundary where you have -1, 0, and 1, that's your boundary, basically. You have -1, you have 0, and 1. You've been given. So what do you use to check the values? And most often, when developers are writing their codes, a lot of errors could get introduced at the boundaries. So that's where you identify the set of test data that you need to use to be able to pick up any invalid, to pick up anything invalid peradventure the developer has introduced that. So for your valid test case, you're going to use one. Okay. If you use one, it should give you the same result. Like, you shouldn't fail. If you use zero, it shouldn't fail. But don't forget there is a -1 somewhere just before one. Now, if you use -1 and it doesn't fail, something is wrong, because you're testing that value. In fact, by just testing -1, you don't need to go and test all the way to -10, -20. -1 is enough for you to test, because you could be working on a project where there are loads of data to use for your testing. So it helps to expose discrepancies in specification, basically. So so we have that. We also have the decision table. I'll come with an example next week. We have a state transition. Yeah, all of that use cases are better. They are better understood when you have some sort of examples and diagram that you can see. So we also have categories of test case design, experience-based testing. Okay, I think I can quickly touch on this in a minute. You know, some of us you have experience working in a different environment entirely. Maybe you've been working on a school portal, secondary school portal, or primary school portal. You understand what is required there and all that. You've worked maybe as a tutor or whatever, as a teacher, and you know the in and out of what should be on a website for any school in the UK. And then you get a job as a software tester in a software company, and they're developing a website for a school. Okay. So number one, you've got some level of experience. Okay. And number two, you've got testing skills as well. So you can actually combine that. Okay. Say they haven't even given you a specification, but you basically understand what they're saying. So you can fall back on that in a place where there are no adequate specification to derive the test case. So that is where sometimes your residual knowledge of things helps you in a job role, even if you've not even done testing before. If you're an accountant and you change your career to a tester, and you are being asked to test the software that is an accounting software, so you would also be able to apply your experience on it, and you also be able to apply your testing skills. So error guessing is very simple techniques. It takes advantage of your tester skill, your intuition, and experience with similar applications to identify special tests that may not be easy to capture by the more formal techniques. Okay, so this also happens kind of similar. You can also guess where error are likely going to be introduced in an application. So that is that. So exploratory testing, I think we all do exploratory testing at some point or the other. So sometimes I would say, for example, I've been on projects where maybe a web application project, and I get there, they'll say, okay, these are documents, and all. Sometimes you get bored with documents. So I just basically say, if the project have we got a test environment for the project? I want to get familiar. I want to see what the system looks like. And that helps you as a tester, because you just want to familiarize yourself with what they've got, because you could just be reading documents. They don't have screenshots. They don't have anything there. They don't have any diagram, nothing, just written documents, and you're already yawning your first day at work. And if you are lucky enough, just ask them, have you got a URL? Have you got anything I can look at so I can just get familiar? Ask for the test environment. Please do not touch their production environment. You don't want to get sacked on your first day at work. You don't want to introduce anything into it. So ask for the test environment, play around with it, because you are basically not looking at it from the angle of, this is what the requirement says. You're looking at it from, okay, I want to get familiar. I want to know what this functionality is. So you just click around. But when I say click around, just click around objectively as well. Okay, so exploratory testing also helps to pick up some specific bugs, which by use you know, and you must, if you find a bug in exploratory testing, you must be able to reproduce it, okay? You must be able to, you know, reproduce it if it's, especially if it's a bug that is really critical. Sometimes we don't find that just by looking at the requirements. So the tester's experience also counts there. Okay, so next week, we'll touch on test management. And of course, I have promised you that we'll have some examples. So please come ready for examples of all these testing techniques. It's important that you understand them. I don't, if you are a manual tester and you also want to have some sort of edge in the market, you need to understand testing techniques, okay? You need to be able to apply that in your testing wherever you find yourself. Testing is not just to enter username, enter password, submit. What if you find yourself working on an application that is not a website? Okay, it's just data, or you have requirements, you have business rules, you have business logic, you have business rule that is having less than, greater than, you know, all of that. So what do you do? How do you apply that? That's where you need the testing techniques. Please make it a date next week. Thank you very much, everyone. 2 minutes past my time. Okay, what would you need for next class? Come with your notes. I believe everyone has their notes already. Come with your notes and pen, and possibly try and make sure you are able to navigate to a different screen. If you are watching, you could be watching, listening on your phone and doing stuff on your laptop or your desktop. Okay, give yourself to prepare, just prepare, because we're going to get hands-on. Yemi and I are going to be here, and we'll be able to explain some things if they are not clear, but you need to understand all this part of testing is really fundamental to you as a manual tester, and it helps you just grow into automation testing without, you know, without any fear of, oh, I don't know what I'm doing, or I don't know what I'm going to do on my first day. Okay, thank you very much, everyone. Yeah, sure. Phone and laptop, absolutely. Absolutely. Thank you, Alex. Thank you, Akbil. All right. Sure. I see Yemi has been answering some questions here. Yes, yeah. Just giving your best, and that's it. You'll be fine. Anybody can test. You remember we said that in the earlier test, in earlier slide. Yeah. Okay. Okay. Well, thank you. All right, I'm going to be saying good night to everyone here. Have a blessed week, and make sure you maybe to listen to video again, or do your own research. And I would also say read up on test case design techniques as well. Yeah, it will help you. Yeah. All right. Thank you, Buki. Thank you, Flo. Have a good night, everyone. God bless.